Okay, in this video, we will still solve problems about areas between curves, but this time we consider an alternate solution, not only considering vertical rectangles. So here's our first problem. Find the area bounded by the graphs of y equal to x squared, y equal to 2 minus x, and y equal to 0. So first is we sketch the graphs. So y equal to x squared is a parabola opening upward. So x equal to 0, y equal to 0. Okay, so this is our parabola, y equal to x squared. The second function is a line, y equal to 2 minus x. So if we use intercept, when x is 0, y equals to, and when y is 0, x equals to also. So when y is 0, x equals to, when x is 0, y equals to also. So there na. So i-plot na to. This is our line. And the third function, y equal to 0, or simply the x-axis, this one. I mean, this is the equation of the line. And this is our third function. So this is the bounded region. Notice that for the bounded region, if you will consider a vertical rectangle, okay. Sa blue and yellow, the upper graph is a parabola, the lower graph is the horizontal line. Whilst the other portion, it's line minus a horizontal line. So, okay. So first, let us locate this point of intersection. So it's between the line and the parabola. So we equate that to this point. Okay. Parabola x squared equals line 2 minus x. And then rearrange x squared plus x minus 2 equal to 0. And then factor out. And then you will have x equal to negative 2 and x equal to positive 1. Of course, pag extend mo ang parabola and also the line, they will intersect sa point on the second quadrant when x equals negative 2. But since our focus is on this region, the first quadrant, so we'll just consider x equal to 1. Eh, so this area, we have two areas, this one and the other one, because they have different conditions. For this, the left portion, the upper graph is a parabola. Sa right portion, the upper graph is a line. And so we are going to break this one into two integrals. So this is our rectangle sa left portion and then right portion. You will notice that the lower graph is 0. Oh, because the rectangle touches the x-axis. So this is for the left portion. X squared lang. Upper graph is parabola, which is x squared minus 0. The lower graph is 0. So x squared lang from 0 to 1. And then sa right portion, upper graph is line 2 minus x minus the lower graph 0. So it's 2 minus x lang. From 1 to 2. And then you get the antiderivative and then evaluate and you will have this. Okay? Antiderivative and then you evaluate. The area is 5 over 6. Okay. Now, let us have an alternate solution. Originally, the first solution is we considered vertical rectangles. as what was explained using Riemann sum. Okay, we used vertical rectangles. Okay. Now, the result, if you will use vertical rectangles, the result is the region is subdivided into two parts or two portions, left and right. Now, an alternate solution is to consider a horizontal rectangle. This one. Notice that for a horizontal rectangle, okay, let's compare. Pag vertical rectangle, the fundamental theorem of calculus, ang nakasulat dito, pag vertical rectangles, integral of f of x minus g of x. Diba? Now, kay vertical man. Pag horizontal, bali na sad. F of y minus g of y. Oh, bali, y equals f of x. Diba? Oh. When you solve for x should be equal to x is f of y equals f of x equals f of y. So, pag horizontal rectangle, you will notice na from the lowest portion up to the highest part, the graph at the right is the line and sa left is a parabola. Consistent. Oh, therefore, uh, there's no need to break the area into two integrals. It's different sa vertical. Because sa vertical, dili consistent. From 0 to 1, the upper graph is parabola. From 1 to 2, the upper graph is a line. Whereas, if you will use a horizontal rectangle, the graph at the right is always a line, always the line, and the graph at the left is always the parabola. Even if you consider sa lowest part, it will still be line minus parabola. Sa upper part, line minus parabola. So, consistent. No? Okay. So, since horizontal ang rectangle na to, f of y, f of y, g of y. Diba? So, and now our thickness will now be dy. So, vertical, dx man, dy. So, this is x sa line, which is f of y sa line, and this one is x sa parabola. Now, take note, ang area na to is area sa rectangle. And area is base times height man. So, our base is x sa line, this one, xl minus xp, this one, times height dy. So, let's solve for xl. It's very simple. X is simply 2 minus y. While sa parabola, we solve for x, that's square root of y. Okay? So our area is this. X sa line, area of rectangle, base times height. So our base is x sub L minus x sub B. X sub L, line, minus x sub B. X sa parabola, square root of y. dy. And you integrate, integral of 2, so 2y, integral of y squared over 2. Square root of y, or y raised to 1 half, the integral is y raised to 3 halves over 3 halves. So reciprocal is 2/3 from 0 to 1. And then you evaluate upper and lower limits. The answer is 5 over 6. If we check this one sa previous answer, it's the same. No? So that's the advantage if you will use a horizontal rectangle. The other problem, find the area of the region bounded by the parabola y squared equal to 2x minus 2 and the line y equal to x minus 5. So let us sketch the graph. Sa parabola, when y is 0, x equals 1. Or y is 0 transposed to 2 equals 2x, so x equals 1. Now, dili pwede na x is less than 1. Like for example, if x is 0, y squared equals negative 2. And dili pwede. Y squared equals negative 2. So, x must be greater than 1. So, for example, if x equals 3, then y squared equals 4. Y equals plus or minus 2. So when x equals 3, y equals plus or minus 2. So it's a parabola opening to the right, like this one, on a parabola. You can substitute any value of x. X equals 2. 2 times 2, 4. 4 minus 2. Y squared equals 2. So y is equal to plus or minus square root of 2. So it's a parabola opening to the right. For the line, y is equal to x minus 5. When x is equal to 0, y equals negative 5. Sorry. This is the equation of the parabola. Again, for this line, if x equals 0, y equals negative 5. There. And when y is 0, x equals positive 5. Transpose 5. This one. And connect the 2 points, you have the line. So this is the bounded region. And this is the equation of the line. Y equal to x minus 5. So let us locate the points of intersection. This one and this one. Kine and this one. So we equate the two functions. Now, by equate the two functions, the other one is y squared, the other one is y. So it's either, ang pag-equate mo is y equal to y or y squared equal to y squared. Depende lang sa. So, to get rid of the radical sign, let's equate y squared equal to y squared. So y squared 2x minus 2y squared x minus 5 squared. Yan na. So y squared 2x minus 2 y squared x minus 5 squared. And then you simplify and then combine like terms, you have this. And then factor out and we get x equal to 9 and x equal to 3. And then simple. When x equal to 9, this one, x equal to 9, our y is equal to, when x equals 9, 9 minus 5, y equals 4. And when x equals 3, 3 minus 5 is negative 2. So for this point, this is 3 negative 2. Na, and this point is 9, 4. Okay. So this is our bounded region. Duha sa subdivide na to into two regions. Okay, this one. Because for this portion, our upper graph is a parabola. The lower graph is also a parabola. While from 3 to 9, the upper graph is parabola. The lower graph is a line. Okay. So, this is rectangle for area 1 and rectangle for area 2. Now, for area 1, by symmetry, this is y of parabola. Because if you plot a point, From the origin, ano ta? X, Y. So from the x-axis up to that point, this point, up to this point, it's y, no? So therefore, for this rectangle, the height of the rectangle is 2y times dx. So the area of this rectangle, 2y times dx. Okay, this one. 2 times y. Ang y sa parabola is square root of 2x minus 2. So 2y from 1 to 3, from 1 to 3. X na dx from 1 to 3. And for the second integral, it's upper minus lower, parabola minus line. So parabola, y of parabola, y is square root of 2x minus 2 minus y of line. Ang sa line is x minus 5. Okay. So next is, we can separate the two terms. We have this. First term, second term, this one. And the third term is x minus 5. And to integrate manually, I mean, you can solve this one using your calculator. But if you want to integrate this one manually, you can make use of the u substitution. So for the first term and second term, let u be equal to 2x minus 2. Du equals to dx. Oh, dx equals du over 2. The result is this will be square root of u and du over 2. And we can use the power rule. Now, by changing the variable from x to u, we are going to change the limits because these limits 1 and 3, x is so, pag change the variable u and then du, i-change mo na siya. So, when x equals 1, u equals 0. So 0 na. And when x equals 3, 3 times 2 minus 2, 4. 0 to 4. So sa second integral, when x is 0, when x is 3, you have 4. And when x is 9, 2 times 9, 18 minus 2, you have 16. Okay, so 0 to 4, 4 to 16. And for the third integral, let u equal to x minus 5 du dx. So, u du lang siya. Again, power rule. Okay. Okay. So, this is what happened, no? 2 square root 2x minus 2 is u. And then dx is du over 2. Okay. And 0 to 4, the second term, 4 to 16. 3, 9. And then for the third term, when x equals 3, 3 minus 5 is negative 2. And when x is equal to 9, 9 minus 5, u equals 4. So negative 2 to 4. So makancel Uh, makancel lang to. And square root of u du, the integral is u raised to 3 halves over 3 halves, or reciprocal 2/3 from 0 to 4. And then this one, square root of u du, u raised to 3 halves over 3 halves, but you have 1 half, so makancelan to, the result is only 1/3. And then u squared over 2. And then you evaluate. First term, second term, third term. And then compute. The area is 18. Okay? Now, it's a very long solution if you use vertical triangle because you have to cut the region into two parts. Now the alternate solution is this. Instead of instead of analyzing vertical rectangles, let's consider a horizontal rectangle. Because if you consider a horizontal rectangle, the graph at the right is a line and the graph at the left is a parabola from top to bottom. So if you consider a rectangle here, the graph at the right is a line, at the left is a parabola. Sa bottom part, right is line, left is parabola. So consistent. Therefore, there's no need to break the area into more than one integral. Okay. So again, you have dy and then x a line and then x a parabola. So our area for this rectangle is base x sub L minus x sub P times dy. Our x line is y plus 5, okay, transpose 5. So x equals y plus 5. And sa parabola, to solve for x, transpose and 2. So you have y squared plus 2. And then since we have 2x divided by 2, so we have x equals y squared plus 2 all over 2. This one. And then combine like terms, y squared over 2 minus, no? 2 over 2 is 1. So 5 minus 1, you have 4. And minus y squared over 2. So you integrate y squared over 2 for y cube over 3 times 2, you have 6. From negative 2 to 4. Because y mata dy. So our limits must also be y. Negative 2 up to 4. So evaluate upper and lower limits. The answer is 18. Same lang kaganina. So from the two problems, we're able to differentiate the two solutions using vertical rectangles and horizontal rectangle. Because there are problems na mas easier to analyze using horizontal rectangle rather than vertical rectangle. So at least you have the option already what to use, a vertical rectangle or a horizontal rectangle. Uh, So I hope that you have learned from this video. Thank you for watching.